Good day guys, this is your tutor engineer. Today we'll be doing a grade 12 question based on acids and bases. So let's get on with it. A tanker truck traveling to Arizona overturned and spilled this much of a volume of a nitric acid with a concentration of 0.3 mol per dm cube. Sodium hydroxide was used to neutralize some of the acid, and the excess nitric acid drains away into the nearby lake and reacts with 250 cubic centimeters of the carbonate ion. So this will be forming a two-step reaction process. This will be the first step, where the nitric acid, we've been told that it has the initial volume of, on this track, initially on this track, the volume is 5120 cm cube of the nitric acid, and then the concentration is 0.3 mol per dm cube. So this all belongs to the nitric acid. It is going to be an excess reagent when reacting with sodium hydroxide. So not all of the sodium hydroxide will be able to neutralize this acid. The excess part of it is going to drain into a lake. So now let's kind of draw a lake here. Let's say a lake, for argument's sake, is going to come here, where the spillage of the nitric acid will flow into. So the lake contains what? The carbonate ions. So now let's write here, we've got a lot of carbonate ions. The volume of the carbonate ions is 250 cm cube, and then it's going to neutralize this acid completely. It means you won't have an excess acid after it reacted with the carbonate ion in the lake. So this will form part of the second type of reaction. So I'll call it number 2. Then number 2, the excess nitric acid will react with the carbonate ions. When that reaction happens, it will always give the nitrate ions plus carbon dioxide plus water. That's going to be our product after the second step reaction. So now let's get to the first question. The first question says, define the acid in terms of Bronsted-Lowry theory. So basically the acid is the H plus ion donor. That is as simple as that. So the second question is, calculate the initial number of moles of the nitric acid. Okay, already we've got the volume and the concentration for the nitric acid. So that should be much easier. Using the formula C is equal to N over V, we'll be able to calculate the number of moles. The concentration is 0.3. Then you need to get the number of moles, the volume. We can just convert this cm cube to dm cube. So now this is going to be 5.1 to dm cube if you convert it. So the number of moles will be N is equal to 0.3 times 5.12. That means the number of moles will give us, if you put this number on the calculator, it will give us 1.536 mole. Remember, this is of nitric acid. I'll write this as 7.2, or I can also write next to 7.2. Sorry, it's 1.536 mole of nitric acid. 7.3, write a balanced equation using a chemical formula to show how the nitric acid reacts with the carbonate ion. We've already written down the equation there on top. Okay, for argument's sake, let's write it again here. We have the nitric acid plus the carbonate ion. Remember, the product is going to be a salt plus carbon dioxide plus water. So let's check if this equation is balanced. First of all, you've got 1C, the carbon is balanced. And then what about the hydrogens? You've got one hydrogen, then you've got two hydrogens on the right hand side. So the hydrogen is not balanced. Let's balance the hydrogen. So we'll write a 2 here. Now the hydrogen is balanced. The nitrate is going to be in balance, so on the right hand side we'll write another 2. Now the nitrate will be balanced. Everything else now seems to be balanced. You can check the oxygen. You've got 6 on the left hand side plus 3, which is 9. Then you've got 6 on the right hand side plus 3, which is 9. So everything now is balanced. So that would be question 7.3. Then 7.4 says, if the concentration of the carbonate ion is 0.2 mole per dm cube, calculate the number of moles of sodium hydroxide used to neutralize the acid spill. Now they added another element for, let's go back to color blue. The concentration of carbonate ion 0.2 mole per dm cube. Obviously, this will give us the number of moles of the carbonate that you can calculate from this information. Okay, let's go back to color green. We'll say the number of moles using this formula. So the concentration is 0.2 is equal to the number of moles divided by the volume. Converting same cube to dm cube, you'll get 0.25 dm cube. So basically the number of moles will be 0.2 times 0.2 times 0.25. That will give us 0.05 mole. So this is of carbonate ions. Remember, the question is calculate the number of moles of sodium hydroxide that was used to neutralize the acid. So we're going to go back all the way until step number 1. This is from step number 2 reaction. So remember, we've just calculated the number of moles of, let me use a color red, the number of moles of carbonate ions, and then we found them to be 0.05 mole. Now 0.05 mole completely neutralized the excess nitric acid. How much was it? You look at the ratio of the balance equation. You've got 1 here and then versus a 2. It means the corresponding number of moles for the nitric acid is going to be double, meaning it's going to be 2 times 0.05, which will give us 0.1 mole of nitric acid. So that was the excess that spilled into the lake. So it was 0.1 mole of nitric acid. Now that's not what you're supposed to calculate. You're supposed to calculate the ones that reacted with. The question is regarding sodium hydroxide. Okay, now to get back to sodium hydroxide, we know that the initial number of moles in total for nitric acid was 1,536 initially. Out of that, 1,536 managed to react with sodium hydroxide. So how much of it did react? It was 1,536 mole minus the one that spilled into the lake, 0.1 mole. So the answer here is going to be 1,436 mole of nitric acid that reacted with then the sodium hydroxide. So we can write here the nitric acid was 1,436 mole, and then that is how much that reacted with the 1-to-1 ratio. Also, you're going to have 1,36 mole of sodium hydroxide. since you've got a 1-to-1 ratio. So that will be our answer. Our answer here, since it's just the number of moles, is 1,436 mole of sodium hydroxide. Now 7.5 says if the pH of the nitric acid solution of the nitric acid and the sodium hydroxide solution is greater than 7, the pH of the nitric acid and the sodium hydroxide solution is greater than 7. So that is from the first reaction. Is this statement true or false? The statement will have to be false, because in order for the pH to be greater than 7, that means it would be basic. Greater than 7 means basic, and then less than 7 means acidic. So that's pH greater than 7, that means basic. Less than 7 means acidic. Remember, nitric acid was excess, so the solution is actually less than 7. It's not greater than 7, so that would be the reason. So let's get to the final question. It says here, the pH of the lake before the spill was 13. So it means it was basic when it's 13. The pH of the lake after the spill is 4, meaning it's acidic. The question is calculate the concentration of H3O plus ion added to the lake. How much acid was added to the lake? Okay, let's write the formula for the pH is minus log H3O plus. So initially the pH was 13, so that would be minus log H3O plus, and then there is a log with a base of 10. So now in order to solve for H3O plus, we'll apply the mathematics, then the 10 will become the base this side, and then the minus will join the 13, and then we'll have exponent of minus 13. That will be mole per dm cube of H3O plus. That is initially, but the pH was reduced to 4. So now we'll do another parallel calculation here when the pH is 4. So that is a 4 is equal to minus log H3O plus. Imagine here there's a log has got a base of 10, so solving for H3O plus, you'll get 10 here, then minus 4. The unit is mole per dm cube. That will be the concentration after the acid was added. So that means here the H2O plus added would have been this 10 to the exponent minus 4 minus 10 to the exponent minus 13. The difference between the two will be the answer, which is what? So if you put 10 to the exponent minus 4 on your calculator, then you say minus 10 to the exponent minus 13, then you get 9,999 times 10 exponent minus 5 mole per dm cube of H3O plus ion. So that's it. So if you like the lesson, please hit the like button and don't forget to subscribe.